the rules for parallel circuits to solving one. So here is the first parallel circuit I will give you. We have a 4 ohm resistor. Let's call it R1. We're going to have an 8 ohm resistor, so R2, 8 ohms. And do I want to add a third? Let's just leave it at this. And let's make this, let's make this again, V total is 120 volts. So I want you to solve, find the current across each resistor, and the total current in the circuit, as well as the equivalent resistance of this circuit. Remember, equivalent resistance is just another way of saying total resistance. Okay. So we're still going to use our RIV chart. So hopefully you start to appreciate the value of a tool like this. And we're always going to write the number of resistors we have, 1 and 2, plus we need a space for total. But remember, we need to be careful because we're no longer dealing with a series circuit. So the same rules do not apply here, right? In a parallel circuit, we actually have voltage is the same everywhere. Our current is going to be additive, right? So we'll have I total approaching this junction. We'll have some of that current, which we'll label I1, going through resistor 1, and then the rest of that current, which we can label I2, going through resistor 2. It will rejoin at this junction, right over here, and I total will return to the voltage source. So let's write everything that we know. We know resistor 1 is 4 ohms, and we know resistor 2 is 8 ohms. We can no longer just add these, because adding resistors in parallel does not increase the resistance of the circuit. As we saw before, it decreases the resistance of the circuit. We don't know anything yet about the current. However, we do know that the total voltage is 120 volts. So usually I'll say to you, okay, start where you have the most information. I am going to argue that in this problem, there are 2 possible places that you can start. And the place I'm going to suggest first is what you know about voltage, is that V total equals V1 equals V2. No matter which place I connect my little voltmeter, I'm going to get the same reading. So if I measure across resistor 2, I'm still going to get 120 volts. If I measure across resistor 1, I'm still going to get 120 volts. So let's write those in right off the bat. And I'm going to finish this expression by saying V total equals V1 equals V2, which is equal to 120 volts. Now I have sufficiently shown my work for what I just did. Well, now there's 2 paths I can take, and I'm going to argue, let's just take the easier path. I could find my equivalent resistance, but we know that that formula, as we tried out up here, is kind of annoying to deal with. So let's just start where we'll have the most ease. And I'm going to start by finding I1 using V equals IR, because this relationship still is preserved. Okay, so we'll still be able to use Ohm's law. So I'm going to say V1 equals I1 R1. In other words, 120 volts is equal to an unknown current times 4 ohms. Well, clearly we're going to be drawing 30 amperes. That is an insane amount of current. Okay, so maybe I didn't choose the best numbers here, but we'll just deal with it. Okay, I'm going to now do the exact same thing for resistor 2 and figure out how much current is going through that second path. So V2 equals I to R2. In other words, I have 120 volts is equal to I2, which is unknown, times 8 ohms. So I'm just going to do it right now. So 120 divided by 8. Okay, 15. Should not have needed to calculate that. So I2 is 15 amps. We said, sorry, I1 is 30 amps. So let's plug both of those in. So this is going to be drawing 15 amperes. And what we know about current is that whatever our current is from I1, 30 amps, will be rejoined by the current from I2, which is 15 amps, and therefore our total current should simply be 45 amps, because I total is equal to I1 plus I2. So now we have 30 amps plus 15 amps, which is 45 amperes of current. Now I'm going to write that value in. And at this point, our chart looks as follows. So all that is left missing is our equivalent resistance. And as you can see, we can either go horizontally to find it using V equals IR, or we can go vertically using 1 over REQ is equal to 1 over 4 plus 1 over 8. So I'm going to do it both ways so that you can see it'll come out the same. You won't always have the freedom to do this. Okay, so I want to say REQ is equal to V total over I total. All I did was take V equals IR and rearrange it to isolate the R. So R equals V over I, right? So I'm going to take my 120 volts and divide it by 45 amperes, and that should give me my equivalent resistance, which is 2.7 ohms. Let's see if we solve it the other way, we get the same answer. So, or we can use 1 over REQ is equal to 1 over R1 plus 1 over R2. So let's do that. 1 over REQ equals 1 over 4 ohms plus 1 over 8 ohms. First, we should really get a common denominator, or you can convert these into a decimal. I'm going to just get a common denominator, so I'm going to say this is the same as saying 2 over 8. So now I can say 3 over 8 ohms. And I need to still take the inverse of that, right? I'm not done, because I really want REQ. So REQ is equal to the inverse of 3 over 8. In other words, 8 over 3. And I got 2.7 ohms. It is exactly the same as what I calculated in the previous method. So we are in great shape, right? 2.7 ohms from method 2, 2.7 ohms from method 1. And do I need to fill it into my chart? No, but I'm a little bit crazy. Remember, these do not add. 4 and 8 should not add to this, because we know that adding more resistors in parallel should decrease the total resistance, as it did. Okay. Now I just want to check to see if it's still recording. Okay. If I I wanted to get a measurement of the current through branch 1, right? Just across resistor 1. Let's say I want to get that 30 amp measurement. How am I going to do it? Where should I put the ammeter? Well, there's two places I can put it, but it definitely needs to be either after this first junction, so right here, or before the junction where it rejoins current 2. So either of these are going to measure my 30 amps or I1. We'll measure I1. If I wanted to measure I2, I could go anywhere after junction 1, right? I can go anywhere after junction 1 or anywhere before junction 2. Okay, as long as the ammeter sits somewhere in that path, I will measure I2 or 15 amperes. So just know that. If I want to measure I total, I need to go anywhere before junction 1, right, between the source and the first junction, or between the low voltage end of the source and junction 2, right? As long as it hasn't split yet, we're in good shape. Okay, so now I want to give you one more example.